Hello, welcome back to Larry's Classroom. Today we're going to discuss powers of 10. The number system we use is based on powers of 10. And we call this the decimal system. Anyway, we're going to give a few examples. Here's a number. So you can read it a little better. 3,275. I'm sure you can all read that number. What does this mean? This means that's the 3 times 1,000 plus the 2 times 100 plus the 7 times 10 plus 5 times 1. 3,000, 3 times 1,000. 200, 2 times 100. 70, 7 times 10. 5, 5 times 1. We can also express this in this fashion. We can say this is 3 times 10 to the third plus 2 times 10 to the second plus 7 times 10 to the first plus 5 times 10 to the 1 there, 10 to the first, 10 to the 0. 10 to the third power is 1,000, which we have there. 10 to the second power is 100, which you can see right there. 10 to the first power is 10. And we have an important concept that we need to remember. 10 to the 0 power equals 1. As a matter of fact, any number to the 0 power equals 1. 7 to the 0 power would equal 1. 15 to the 0 power would equal 1. And if you were using variables, which you might be doing at some point, x to the 0 power equals 1. Y to the 0 power equals 1. So that's an important thing to remember, that raising a number to the 0 power gives you a result of 1. I'm going to draw a couple little arrows here, just kind of a couple of lines to kind of offset this part here. The 1,000 was equivalent to the 10 to the third power. The 100 was equivalent to the 10 to the second power. The 10 was equivalent to the 10 to the first power. And the 1 was equivalent to the 10 to the 0 power, as we just talked about here. We're going to talk about what we're going to do is, we did this example, didn't we? No, I want to. Okay, we're going to talk about, in all cases here we had positive powers of 10. We had a positive 3, a positive 2, a positive 1, a positive 0. We're going to show a little bit about what happens when we have negative powers of 0, or negative powers of 10, excuse me. We're going to erase this example. Let's say we have this number, 7.371. Well, what does that equal? We can see that the 7 times 1, put parentheses around that 1 to kind of offset it for you, plus 3 times 1/10 plus 7 times 1,000th, or 100th, excuse me, plus 1 times 1,000th. Another way we could write this same number, we could go 7 times 10 to the 0 power. And here we've match that 10 to the 0 power up with that 1 there. Plus 3 times 10 to the negative 1 power. 10 to the negative 1 matches up with that 0.1 or 1/10. Plus 7 times 10 times 10 to the negative 3rd, which this 0.01 matches up with that 10 to the negative 3rd. Plus 1 times 10, well, this is negative 2nd, excuse me. And I wrote this wrong here too. That should be 0.01, not 0.001. Plus 1 times 10 to the negative 3rd. And now we have a match between this. So 7 times 10 to the 0 power, this piece, 1, 10 to the 0. Plus 3 times 10 to the minus 1, 10 to the minus 1, 0.1. Plus 7 times 10 to the minus 2, 10 to the minus 2, 0.001. Plus 1 times 10 to the minus 3rd, 10 to the minus 3rd, 0.001. And one thing you might notice here, 10 to the minus 1, the negative 1 tells us 1 decimal place. 10 to the minus 2, the negative 2 tells us 2 decimal places. 10 to the minus 3, the minus 3 tells us 3 decimal places. Another thing I want to draw out for you, and we've kind of done this already, but 10 to the minus 1 equals 0.1, which we've demonstrated there, but that is also equal to 1 over 10 to the first, which equals 1/10. And which you may or may not notice here is this 10 to the negative 1, we move that to the denominator from, this really is the numerator, because you can put the 1 over that on any number. The sign of the exponent changed when we moved from the numerator to the denominator. We'll do a couple more, 10 to the minus 2, and that is going to equal to 0.001, 2 decimal places from the negative 2, which we showed up here, which is also equal to 1 over 10 to the positive 2. We've changed the decimal sign of the exponent, we moved it to the denominator, which, if we do the math, 10 times 10, it's 1 over 100, or 1/100th. 10 to the minus 3 equals 0.001. 3 decimal places, negative 3, which is equal to 1 over 10 to the positive 3. We changed the sign, we moved it to the denominator, which is equal to 1 over 1,000. 1/1000th. You may have noticed, whenever we had positive powers of 10, like 10 cubed, that was equal to 1,000. The 3 matched the number of zeros. 10 squared equals 10 to the second power equals 100. The 2 matches the number of zeros. 10 to the 7th. 10 to the 7th. We'll go with that one. 1. The 7 matches the 7 zeros. So with positive powers of 10, if you wanted to write it out, you would put a 1 and the number of zeros that matches the exponent. Now we should do a quick talk about absolute value because we're going to be utilizing that here in a few. Absolute value, -7. The absolute value of -7 is 7. Basically, the absolute value is is the value of the number with a positive sign, which we sometimes call the magnitude of the number. And a lot of times you will see a couple of bars with a -7 or negative whatever. That indicates absolute value. So when you put them bars around the number, that usually means you want to use the absolute value of this number. And the absolute value of -7 is 7. A few more examples. -2. Absolute value of -2, which is the magnitude, the value of the number, the positive portion of the number, is simply 2. 0, this is an interesting one. If we had a -0, could we put a -0? Well, the absolute value of 0 is equal to 0. If I put -0, that still would be 0. It doesn't really change anything. Now let's draw a number line quickly here. Got a number line. 0. -5. -10, and over the side +5. +10. Okay. So on the number line, if you're not familiar with it, positive values usually go to the left. Negative values usually goes to, well, this is to the right, excuse me. Positive values to the right, negative values to the left. So let's look at these numbers that we've just looked at, dealt with here. -7, where is that on the number line? 1, 2, start from 0, -1, -2, -3, -4, -5, -6, -7. So that -7 is right there. And now let's think about the distance from 0. 1, 2, 3, 4, 5, 6, 7. It's 7 units from 0. And distances we always measure as positive. So really the absolute value is the distance on the number line from 0. Let's look at -2. 0, -1, -2. -2 is 2 units from 0. Of course, 0 is 0 units from 0. Let's plot the absolute values of the numbers we're dealing with. The absolute we found that the absolute value of -7 was +7. So if we go out here to +7, we'll put +7 there. And I'm going to put -7 there. 1, 2, 3, 4, 5, 6, 7. +7 is 7 units from 0. And 1, 2, 3, 4, 5, 6, 7. -7 is 7 units from 0. So the absolute value just takes into account how far from 0 that number is. And you'll notice that the positive was to the left, the negative indicated to the right. We'll do the -2 here also. We'll put the absolute value of -2 right here. Well, -2, 1, 2, -2 units, but it's 2 units of distance, but the negative indicates it's to the left on the number line. The +2 is 2 units to the right, and the positive, of course, we don't have to write positive. If we leave the the positive symbol off, the positive is implied, but that indicates that we're 2 units to the right of 0. And we find that the absolute value, make that look like a 2, Larry, that the absolute value of the number, and if it's a negative number, is the same distance from 0. So really all we're wanting with absolute value is how far from 0 on the number line a particular number is. We just drop the negative sign, but at the same time, we say the absolute value is 7. I put the bars on here this time. That's equal to 7. The absolute value of negative 7 equal to 7. Absolute value of negative 6 equal to 6. Absolute value of 6 equal to 6. But in all cases, this number is the distance from 0. The distance from 0. The distance from 0. And being we can think of it as a distance, we don't ever say we drove negative 50 miles to get to visit our uncle on the weekend. Now, we already talked about this a little bit, but we're going to review it real quickly. Negative powers of 10. 10 to the negative any number in itself is a positive whole number. Powers can be other than whole numbers, but for our purposes at this point, we're only going to deal with whole numbers. So, I'm going to erase that line. I'm going to erase this too. 10 to the negative n equals 1 over 10 to the n. And here we see what we talked about before. The sign went from negative to positive when it went from the numerator to the denominator. And that also indicates the exponent will indicate the number of decimal places. 10 to the negative 2 is going to be equivalent to, there's going to be 2 decimal places. 0.01. That's, well, let's go ahead and do 2 steps here. 1 over 10 second power. The exponent changed sign when it went from the numerator to the denominator, but it also equals 0.01, which we'll notice 2 decimal places, 2, 2. Do one more of those. 10 to the minus 4. Kind of did some already. That's equal to 1 over 10 to the 4th. Sign change when it's from the numerator to the denominator. 0.0001. 4 decimal places. And we have the 4 in the denominator, or the negative 4 in the numerator. So we're going to practice a little bit with some of this. We've done some of these already. Let's just do a couple of them because we've already done a bunch of them. 10 to the minus 4. I think we just did that one. That's equal 1 over 10 to the 4th, which is also equal to, remember, now we're dealing with a positive exponent, 1 over 1 and 4 zeros. 10,000, which is also equal to, because this is a negative number, we're talking about decimal places, 0.0001. 4 decimal places. A negative 4, positive 4, 4 zeros. This is a comma. And remember, this is the tenths place, the hundredths place, the thousandths place, the 10,000ths place. Exactly what we saw here. We'll do one more. 10 to the minus 6. That's 1 over 10 to the 6th, which will be 1 over 10 and 6 zeros. Negative 6, change sign, 6 zeros, but that's also equal to 0.1, 2, 3, 4, 5. That's 6 decimal places, 6 zeros, positive 6, 6 zeros, negative 6, 6 decimal places. The sign change, we went from numerator to denominator. And this was 1 over 1 million. What do we got here? A tenth, hundredths, thousandths, 10,000ths, 100,000ths, 1 millionths. We're going to do a few more similar type of expression things. We're going to express these as powers of 10, as powers of 10 of 10, and as a fraction. So, first one we got, 0.1. And you probably by now realize that being that's the first decimal place, that's 1/10. But let's express it as a power of 10. We have one decimal place, so it's 10 to the minus 1. The negative 1 indicated one decimal place. Now we want to express this as a fraction. 1 over 10 to the first. Our exponent changed from a negative to a positive, changed sign, went from the numerator to the denominator, which is just simply 1/10. Let's do this one here, 0.02. Now we have, other than a number 2, we have a number 1, other than the number 1, we're using the number 2. Let's see how many decimal places we got here. 1, 2. And I didn't want to do that. I want this to be a 1. I simply want that to be a 1. We don't want to go there yet. So 1, 2 decimal places here. So that's 10 to the negative 2. 1, 2 decimal places, negative 2. Move the exponent, the power of 10 to the denominator, that becomes 1. The exponent changes signs, 10 squared, 10 to the second power, which is equal to 1 over 100. So there's our decimal expressed as a power of 10, expressed as a fraction. We did this as an intermediate step to get to a fraction. This is actually a fraction too, but we wanted to calculate out the denominator. Here we have a decimal number. We're going to express it as a power of 10. We count the decimal places, 1, 2, 3. So that's 10 to the negative 3 because we're talking about decimal places. Now we move that to the denominator, changes the sign of the exponent, or the power, 10 cubed. And then we calculate out 10 cubed. That's 1 over 1 and 3 zeros. 1 over 1,000. Anyway, so we've done some moving back and forth between fractions and powers and decimals. You'll be doing this from time to time in your calculations if you're doing really any kind of math, but it comes up a lot in electrical calculations. Now we're going to talk about multiplying and dividing powers of 10. We're going to put some rules in here. Multiplying powers of 10. Positive powers of 10. We basically just add the exponents. We add the exponents. Here's an example. 10 squared times 10 to the fourth equals 10 to the 2 plus 4. We're putting addition in the parentheses here to indicate that's what we're doing, which is equal to 10 to the sixth. There's our first rule. Second rule, multiplying negative towers. Negative powers. Powers of 10. 10. We are going to add the exponents. Add the exponents. The absolute value. Add the absolute value of the exponents. That's what I want to say here. Add absolute value. And use the negative sign on the result. So let's look at how we might do that. 10 to the minus 3 times 10 to the minus 2. Well, the absolute value of minus 3 and the absolute value of minus 2 is 3 and 2. So we're going to 10 to the 3 plus 2. But we're going to put that negative sign out front. So this equals 10 to the negative fifth. Now we're going to multiply. I don't want to use this pen. Multiply powers of 10 that have positive and negative. With positive, positive and negative exponents. Okay, so what we want to do is take the absolute value of exponents subtract and use the sign of the sign of the largest So let's do an example here. We have 10 to the fifth, and we're going to multiply that times 10 to the negative 3. Well, what do we have for the absolute value of 5? The absolute value of 5 is 5. What do we have for the absolute value of negative 3? The absolute value of negative 3. Which is largest? 5 has the largest absolute value. So we're going to go 10 times the 5 minus 3. And we're going to use the sign of the largest, which happens to be positive. I'm going to put the positive here just to illustrate a little bit better, but you wouldn't, leaving it off would indicate it was positive. So what do we got? We got 10 to the 5 minus 3, that leaves 10 to the second power. I'm going to erase this, and we're going to do some examples. So let's do a few examples here. We got a 10 cubed times 10 to the negative 6 times 10 to the negative 2. Well, that's a positive 6, excuse me. 10 to the third times 10 to the 6 times 10 to the negative 2. First, we're going to take this piece. We're going to use the rule for multiplying positive exponents, which is we add the exponents. 3 plus 6. 3 plus 6, we'll put it up there in parentheses. And we're just going to continue with the 10 to the negative second. So now we're going to work out this. What do we have? We have 10 to the 3 plus 6, which is 9, which takes care of this first part here, times 10 to the negative second. Now we have exponents with different signs. We want to use the absolute values. The absolute value of 9 is 9. The absolute value of 2 is 2. We want to subtract, and we want to use the sign of the largest. Well, the largest absolute value is 9, so we're going to use the positive sign. We're going to take 9 minus 2, 10 raised to the absolute value of the largest, minus the absolute value of the second, which was 2. And I'll put the plus there, but we don't actually need it, equals 10 to the 7th power. We use our multiplying of the same sign, simplify that, then we use our multiplying of opposite signs and simplify that, and come up with 10 to the 7th power for that. Let's do another example here. Ten to the 5th times 10 to the negative 6th times 10 to the negative 2. What's that equal to? Well, we multiply left to right like our orders of operation says. So we're going to do this multiplication, calculate out, then do the multiplications left. So we're going to do this multiplication first. These are opposite sign exponents. The base always stays the same. 10 is the base. It doesn't change. So we're going to take the absolute value. Absolute value 6 is 6. Absolute value 5 is 5. So we're going to take the largest absolute value, 6 minus 5. And then we're going to use the sign of the largest one. Well, the sign of the largest one, 6 had the largest absolute value. Its sign is negative. So we're going to put that out there. And we're just going to carry on this second multiplication, which we haven't done yet. Now we're going to complete this multiplication. 10, 6 minus 5 is 1. That's what was in the parentheses. But we use the negative sign, so it's 10 to the negative 1. Times 10 to the negative 2. Now we're going to take this here. We've simplified our problem. We've done the first multiplication. We multiply left to right on our order of parentheses, our order of operations. Now we're doing the second piece. 10 to the negative 2. Here we have like signs, but they're both negative. So we add the absolute values, 1 plus 2. We use the negative sign. Well, that equals 10 to, what's 1 plus 2? That's 3, negative 3. Let's get that negative so you can see a little bit better. Now we're going to talk quickly. We've been talking about multiplication of powers of 10, base being 10, and the power or the exponent. We found that we added the exponents basically, and we had some different rules for the signs of them, but the basic rule was we added exponents to multiply. To divide, powers of 10 of 10. Change the sign of the divisor and apply multiplication rules. So we basically convert our division problem into a multiplication problem. Then we use the multiplication rules of the multiplying powers of 10. So here's an example. 10 to the 6 divided by 10 to the minus 3. Now this number in the denominator, that's what we call the divisor. So first thing, I just change the sign of that. How do we change the sign of that? We move it from the denominator to the numerator. So that becomes 10 to the 6th times 10 cubed. Now it was a division problem, now it's a multiplication problem. We moved the divisor, which had a negative sign, to the numerator. We changed the sign of the exponent. Now we just use our multiplication rules. We got both positive exponents in this case. 10, 6 plus 3. We are going to add the exponents to multiply. They're positive exponents. We don't have to do any special treatment of them, so it's 10 to the 9th. So we took this 10 to the 6 divided by 10 to the minus 3. We converted it into a multiplication problem by moving this from the denominator to the numerator, which caused the sign to be changed. Then we add the exponents, and we had our result. I'm going to do a couple more examples. I'm going to leave this up here because I think I got room for it now. We're going to divide 10 to the minus 4th divided by 10 to the 7th. That's a positive 7. 10 to the 7th. Change the sign of the divisor and use multiplication rules. Well, we have a positive 7, so we're going to end up with a negative 7. 10 to the minus 4th. Now we're converted to multiply. We move the 10 to the 7th from the denominator up to the numerator. We change the sign. 10 to the minus 7th. So now this was a division problem, becomes a multiplication problem. Now we apply our multiplication rules. Well, what are the multiplication rules when they are both negative? Add the absolute values, use the negative sign. 10, we're going to put the negative sign there. We're going to add the absolute value of 4 plus 7. We use the negative sign because they're both negative. 10 to the negative 11. That's our result there. I think this is going to be our last example here. A little more complicated. 10 to the negative 1 times 10 to the negative 2 times 10 to the 5th over 10 to the negative 3rd. Well, first let's just convert it all to a multiplication problem. Let's convert this division into a multiplication. So we'll stick with the 10 to the minus 1. And this does not violate the order of operations because we're not actually doing the division. We're just changing the format. 10 to the negative 2 times 10 to the 5th times, now that negative 3 becomes a positive 3. We move it to the numerator. So we'll put an equal sign because we're trying to calculate that value. 10 to the negative 2 didn't change. 10 to the negative 2 didn't change. 10 to the 5th didn't change, but the divisor, which we wanted to convert into a multiplier, did change. The sign changed because it went from the denominator of the fraction to the numerator. Now we've converted our whole string of numbers into a multiplication problem. So let's left to right on the multiplication now. Let's do this piece first. 10. And what are we going to do with the powers? We have both negatives, so we're going to use a negative sign, and we're going to add the absolute value. Absolute value in negative 1 is 1. Absolute value in negative 2 is 2. So we have 1 plus 2. And we will not change anything else yet. 10 to the 5th times 10 to the 3rd. Now we're going to actually do this part. That's 10 to the negative, and 1 plus 2 is 3, times 10 to the 5th, times 10 to the 3rd. So now we're going to do this multiplication. Notice the problem's getting smaller as we do each piece. Well, we got opposite signs here, don't we? Still going to have a base of 10. The base don't change. We have absolute value of 5 is 5, and absolute value of 3, negative 3 is 3. Which is larger? The absolute value of 5 is larger than the absolute value of negative 3. So we're going to use the sign of the 5, which is going to be a positive. I'm going to put the plus there for emphasis. Normally you do not need to display the plus. I'm going to do my parentheses. I'm going to subtract the smaller absolute value from the larger absolute value. So it's going to be 5 minus 3. These are both absolute values, but we're subtracting. And still times 10 to the 3rd. And what does that equal? Well, 10 to the positive, 5 minus 3 is 2, right? Times 10 to the 3rd. We got 1 left. Both positive, we add the exponents, and job is done. Well, I think you can see that, well, let's go ahead and do it. 10 to the 2 plus 3 equals 10 to the 5th. I was going to skip this piece, but, you know, it's not really. When you feel comfortable skipping a section, you can. But the result of this whole thing here was it equaled 10 to the 5th. After we did all the multiplications left to right, we converted everything. The division got converted to a multiplication. Then we did it left to right using the multiply rules. Now I'm going to leave the first conversion. I'm going to kind of show you a shortcut, which you can ignore if you so desire. Don't feel ready for it, but I'm going to show you the shortcut. At some point you'll probably like to. We can take this thing and say this is 10. We simply sum the exponents. I'm going to put it in a big bracket here. We're adding negative 1 plus negative 2 plus positive 5 plus positive 3. So here we've done a single step. We converted this to a single power of 10 with an expression for the exponent. We didn't change any exponents. We changed them here to make it from divide to multiply, but on this step, no exponent sign changes. Nothing changed. Here's the negative 1, there's the negative 1. Here's the negative 2, there's the negative 2. There's the 5, there's the 5. There's the 3, there's the 3. Now we just add them all together, which could be 10 to the negative 1 plus negative 2. That's negative 3 plus 5. That's positive 2 plus 3. That's 5. So we kind of shortcutted it. If you don't feel comfortable doing the shortcut yet, don't concern yourself. At time you'll probably get there. You'll know when you're ready. But I'm going to draw a number line, kind of show you how that went. 0. This is a negative 5. And this is a 5, positive 5. So we started with our first exponent, which was negative 1, right here. And then we added that to that a negative 2. Well, negative 2 means it goes left. 2, 1, 2. Then we added to that a positive 5, which positive 5 means go right. 5 points. 1, 2, 3, 4, 5. And then we added to it a positive 3, which means go right 5 more steps on the number line. And there we ended up at positive 5. So in every case, when we broke it down, we got 10 to the 5th. When we did our shortcut, we got 10 to the 5th. And we used our number line to help illustrate the shortcut, we got 10 to the 5th. Don't worry about the shortcuts at this time if you feel uncomfortable with them. In time, that will all change. Anyway, thanks for coming back. Hope you found today's lesson interesting, and be sure to like and subscribe. And until the next time, keep on learning.